Hi everyone, this is presentation video for my final project for AI class led by Professor Nordling at NCKU in Taiwan in Tainan during the period of spring semester 2020. As you can hopefully see on the screen right now, I have not only chosen to recognize digits 0 to 9 but also all the letters of English alphabet, both lowercase and uppercase. I will try to walk you as smoothly as possible through the Google Colab notebook. You can also download it yourself, run it yourself. It's commented, there are links to external sources, and I just hope it will work for you and you will find all the information you might be looking for inside. So at first, let me terminate the current session of the Google Colab notebook. We can reconnect to a new one and run the code right now real time together, so you can see that everything works as it should and it's fine. Here are all the dependencies that you need. There is nothing special in here, just TensorFlow datasets, which contains the eMNIST dataset that I work with, NumPy for data manipulation, and Matplotlib for plotting. This piece of code loads the dataset into three separated variables: dstrain, dstest, and dsinfo. eMNIST provides several subdatasets. As you can see, I am loading eMNIST/by class. This subdataset contains all the digits 0 to 9 and all the letters of English alphabets, both lowercase and uppercase. I've tried the others, but I discovered that sometimes they are not complete. They might contain all the lowercase letters, but only half of the uppercase letters. It just doesn't make sense. And this one works for me. I recommend using this one. You can just Google eMNIST dataset and you will easily find it. I also provide link in the code. Even though the dataset is contained in the TensorFlow_datasets module, but you have to download it. So that's what's happening right now. The dataset is being downloaded and prepared. I had to do several cuts in the video because this part takes kind of long time. You can check the time in the upper left corner yourself. So don't be surprised if you try to run the code on your own. This part just takes a long time. When the data is ready, I wanted to verify the integrity of the dataset. I got a sample for each of the 62 classes, 0 to 61, and I plotted it in this nice matrix so I can see what is the quality of the samples and if it really contains everything what should be inside. If you just give it a quick look, you might think that the dataset is okay, but if you think more about it, you will encounter two problems. The first one, corresponding digits and letters are underlined with a red line. That's a problem when the digits or letters, they just look alike. For instance, number 1, the letter L, the letter I, it's just all vertical lines. It looks alike, so it's hard or even impossible to predict what it is, even for humans. The second problem is that comes for the letters or digits which are in orange circles. That's just a bad quality of samples or incorrect labeling. You can see that the number 0 is just awful, and in the last full row we have OPQES. There should be OPQRS, so there is E instead of R, so there is some incorrect labeling, and we have to remember that. In this part of code, I'm getting the data ready for feeding into the model fitting process. At first you have to normalize the samples, so divide the values by 255. Then I shuffled the samples, created batches of 128 pieces, and to boost the performance I did caching and prefetching. What is this? You can find in the code in the comments. There are links to the official TensorFlow website and you can read more information about that. Here you can see what my model consists of. I use convolutional 2D layers, batch normalization, dropout layer, flatten layer, dense layer, and softmax layer as the final activator. A few words about why did I choose this kind of structure. I read a lot of articles and papers about classifying digits and letters and both combined. I did some experiments, I tried a lot of various structures, and I kind of ended up with this one. I can't really tell that I used a particular paper or particular article or particular sample code. It's just fusion of all of what I tried, and this works well. I did a training for 20 epochs. One epoch took roughly 50 55 seconds, but with use of Google Colab Pro and GPU acceleration, if I didn't use this, it would take ages. And still, it took some time, so I also did some cuts in the video. I did the training several times, and each time I ended up with similar results. The accuracy for the test dataset was every time roughly 87, really close to 88%, and it started struggling around 18th epoch. Here are the charts for both loss function and accuracy for both train and test datasets. As I mentioned, the fitting started struggling about around the 18th epoch. Even though if it didn't, the progress was so slow, so I don't think I could get any much better results with this model. The test dataset has been already utilized in the fitting process, but I did it one more time. I took a batch and did a prediction on that. I plotted 25 correctly predicted labels and all the incorrectly predicted labels from that particular batch. That means 128 samples. The first plot is not that interesting because it's the correctly predicted labels. Let's have a look at the second one. To understand what's going on, the first label is the correct label and the second label is the predicted one. So let's have a look at what went wrong. I did a red line under all the characters that I think it's not my model's fault that they're being predicted incorrectly. We have two groups of those. First is when they just look alike like another character. For instance, digit 0 and the letter O. Then we have the digit number 1 and the letter L. The second group is when the dataset is just not perfect. For instance, the letter T in the second row, it's supposed to be lowercase t, but it looks like 100% uppercase T. So my model predicted that it is uppercase T, but it's incorrect. Then we also have the digit number 5 and the letter S, also in the second row. And it is just really strange. I would say it's S, but the correct label is 5, so this is just bad quality of the dataset. It's not my model's fault. Let's do a quick summary. 32% of the dataset is considered to be hard to predict or even impossible to predict even for humans because the samples just look alike. For instance, lowercase o and uppercase O. Assume that for each of these hard to predict characters, there is exactly one another option which looks alike. Then we have 16% down because we have 50% probability that we will hit the correct one. So 100 minus 16, that's 84%. We also have some bad quality or incorrectly labeled samples. So let's say any score, I mean the accuracy on the test dataset, which is higher than 82%, is considered to be acceptable and success. I reached a score of 88% accuracy on the test dataset, which is pretty nice. And I read several articles, several papers, and if the authors achieved accuracy like 86 and higher, it was considered to be a big success. But I'm not saying that I'm better than them because they might have had more difficult datasets because they were working with the balanced dataset and this is just another one. So I can't compare this. And also I'm not saying that the model is perfect and it is just a dataset which is bad, because as you can see, the model struggles to predict correctly the letter lowercase u and lowercase m. It also had a problem with the weird f, which you can see on the screen right now in the middle of the matrix. There is some strange point in the left side, but I guess this should be acceptable for the model to work with. So there are some things that can be improved. If I skipped any details that you were interested in, just check the code, it's commented, there are a lot of links, a lot of sources, and I'm pretty sure you will find all the information there. So thank you for your attention. I tried to make the video as short as I could, and I hope you liked the work I did, and I hope I can receive any extra points for the letter recognition, because I missed a few diaries and Yeah, so I would appreciate some extra points. Thank you, Professor, for the semester. You told me a lot about TensorFlow and neural networks and Python. Yeah, it was really interesting. Thank you.